Comment if you can hear me. If you can hear me, please comment if you can hear me. Good evening, I see you. Marvin, I see you. Please, I see you. I see you all. If you can hear me, please comment if you can hear me. Good evening, I see you. Marvin, I see you. Please, I see you. I see you all. I see you, Yvonne. I see you. Alright, I'm glad you guys can hear me. See you. I see you, wisdom. You guys can hear me. I see you all. You wisdom. I see you all. So I'm trying to share the link to all the groups. We are live, guys. Tell someone we are live. Trying to share the link to all the groups. We are live, guys. Tell someone we are live. Alright, so if you are just joining JAEX for the very first time, you can see displaying on the screen, the bottom screen. Please subscribe to this channel. Please subscribe to this channel. Do that quickly. Do that quickly as we're about to start. Do that quickly. Do that quickly as we're about to start. All right, everybody. Your host for today. I believe you all can see me. All right, everybody. I believe you all. Now, quickly, our mission for tonight is to cover solubility. Quickly, our mission for tonight is to cover. All right. So let's proceed. All right. Now, in this topic, we're going to define what are solutions. We'll talk about solvents. We'll talk about solutes. We'll look at solubility itself. We talk briefly on solubility curve, the differences between saturated and unsaturated solutions, and we are going to look at some calculation before we go to bed. Now, ladies and gentlemen, if you are ready, please comment I am ready. If you are ready, please comment I am ready. Now, ladies and gentlemen, if you are ready, please comment I am ready. If you are ready, please comment I am ready. Let me see the comments coming. Let me see the comments coming. Give me that energy. E for energy. E for energy. Comment I am ready. I see you, success. I see you, Bleeze. I see you, Marvel. I see you, Sarah. I see you, Mark. I see you, Wisdom. I see you all. I see you, success. I see you, Bleeze. I see you, Marvel. All right, so let's proceed. Now, we're going to start with the word solutes. What are solutes? Um, solutes are the substance that dissolve in water. I repeat, solutes are the substances that are dissolved in water. So a good example is salt. Salt is a solute that dissolve in water. So what is solvent? Now, to understand solute very well, look at this diagram. Now, in this diagram, you can see salt. You can see my cursor. Look at this diagram. Now, in this diagram, you can see salt. You can see my cursor. Yeah, you can see this salt. All right. So this first image is salt. Now, salt here is solvent. Sorry, it's solute. Now, this second one, now salt here is a solvent. Solute. Now, solvent dissolve solute. I repeat, solvent dissolve solute. Solvent dissolve solute. Salt is a solute. When put in water, the water is a solvent. Now, what is solute? We said solute is that substance that is being dissolved. This is the salt. Salt is this substance that when you put it in water, it dissolves in the water. So the solute is the substance that is what being what dissolved. So a good example is salt. Now moving to solvent. Solvent is that substance that dissolves solute. Solvent is that substance that dissolves solute. Water is the substance that dissolves salt. Water is the substance that dissolves salt. Water is the substance that dissolves salt. So therefore is known as what? Solute, solvent. Now, what is now solution? Now, a solution is a uniform mixture of the solute and the solvent. Now, look at this diagram very well. Salt plus water give us salty water, right? This is the salty water. Now, this salty water is known as the solution. Remember, we said that the salt is the solute and the water is the solvent. Why? The solute is the substance that dissolves, that is being dissolved. Then a solvent is the substance that dissolves the solute, e.g. the salt. Now, the combination of solute and solvent gives us solution. So, the uniform mixture of a solute or a solvent gives us a solution. Do you understand? No, 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 no. Mark, there are other things that can be referred to as a solute. For example, now, sugar can dissolve in water. So, sugar is the solute. Sugar is the solute. Water dissolve the sugar. So, water is the solvent. Do you understand? Even if you dissolve biscuit in water, the biscuit is the solute. So, anything that can be dissolved in a liquid medium or in a solvent is known as a solute. Do you understand? If you understand, say I understand. Say I understand. E for energy. E for energy. Let's move. Let's move on. Keep it rolling, guys. Say I understand. Say I understand. E for energy. E for energy. Say I understand. Keep it rolling, guys. All right. I'm glad. Now, one last information I'm going to pass is this. One last information I'm going to pass is water is known as a universal solvent because it has the ability to dissolve anything in the world. Water is known as a universal solvent because it has the ability to dissolve anything in the world. So I repeat, water is known as a universal solvent because it has the ability to dissolve anything in the world due to its polar nature. So I repeat, water is a universal solvent because it has the ability to dissolve anything in the world due to its polar nature. Now, to be sure that you guys got that, look at this question. Now, this question is for my PTS student, the nursing student, the WAEC, and the JAM. Got that? Look at this question. Now, this question is for my PTS student, the nursing student, the WAEC, and the JAM. Please give me the answer. Please give me the answer. Give me the answer to be sure that you understood it. Please give me the answer. Please give me the answer. Give me the answer to be sure that you understood it. I'm waiting. I'm waiting. Waiting. I'm waiting. You guys are saying D. Are you sure? Are you sure? Sure. Are you sure? Okay, someone said the question is not fully clear. Mark. Okay. Okay. I've not. Where is Bliss? So the answer is indeed D. Yes. Let me mark it. The answer. Let me use a red pen. The answer is D. Now moving forward, because we need to move forward now, real quick. All right, let's move forward. Now, what is solubility? What is solubility? Solubility is the ability of a solute to dissolve in a solvent. What is solubility? Solubility is the ability of a solute to dissolve in a solvent. I repeat, solubility is the ability of a solute to dissolve in a solvent. Remember, what is a solute? Salt is a solute. The water is the solvent. So when solutes dissolve in solvent, solution is formed, and the ability for a solute to dissolve in solvent is known as solubility. Now, moving forward, we'll now talk about the factors affecting solubility. Moving forward, we are talking about the factors that can affect solubility. Number one is the nature of the solute. Number one is the nature of the solute. Number two is temperature. Number two is temperature. Number 3, pressure. Number 2 is temperature. Number 3 is pressure. Then number 4, solvent. The nature of the solvent. Then number 4, solvent. So if you can still hear me, comment I can hear you. If you can still hear me, comment I can hear you. I can hear you. E for energy. So if you can still hear me, comment I can hear you. If you can still hear me, comment I can hear you. Let me know, let me know, let me know, let me know. Tell me you can hear me. I want to see the comments coming. Keep it rolling. Let me know, let me know, let me know, let me know. Tell me you can hear me. Now, if you truly understood the factors affecting solubility, we say number 1 is the nature of the solute, number 2, temperature, number 3, pressure, number 4, nature of solvent. Truly understood the factors affecting solubility, we say number 1 is the nature of the solute, number 2, temperature, number 3, pressure, number 4, nature of solvent. If you did understood it, here is a question for you, my friend. Here's a question for you, my friend. This is specifically a jam question. So Jam is saying tonight, Favor, why can't you hear me? My mic is on. Favor, can you hear me? Why can't you hear me? My mic is on. Mike, where do you want me to explain? Favor, can you hear me? Now, Jam is saying tonight, one of on which of the following is the solubility of gaseous substance dependent? 1, nature of solvent, nature of solute, temperature and pressure. On which of the following is the solubility of gaseous substance dependent? 1, nature of solvent, nature of solute, temperature and pressure. Okay, I'm still waiting for that response. Keep it rolling. Keep it rolling. Okay, I'm still waiting for that response. Keep it rolling. Keep it rolling. All right. You guys keep saying A, 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 A. Now, all right. So the answer is indeed A. Now, all right. So the answer is indeed A. Now, let me explain again because Mark asked me to do that. Now, one of the factors is temperature. Now, we know that when there's an increase in temperature, there's increase in solubility because solubility solely depend on temperature. Number 2, the nature of the solvent. Now, solvent carries polarity, plus and minus, positive and negative. The polarity helps in the dissolving of the solutes. So the nature of the solvent, depending on how much polarity it has, contributes greatly to what? Solubility. Then number 3 is pressure. Now, when there's an increase in pressure of the gas, right, or when there's an increase in pressure, it increases solubility of the gases. Do you guys understand? pressure. Now, when there's an increase in pressure of the gas, right, or when there's an increase in pressure, it increases the solubility of the gas. And the last one is nature of solvents. So for this answer, option A is correct because it carries nature of solvent, nature of solute, temperature, and pressure. So for this answer, option A is correct because it carries. I'm favor. I'm trying my best. My mic is on. Like my mic is on, and I increase the volume. I'm favor. I'm trying my best. My mic is on. Like my mic is on, and I increase the volume. Kingsley, you said it's echoing. My settings here are not echoing. Be sure that you are not multi-streaming because that is the only way it can be echoing. My settings here are not echoing. Be sure that you are not multi-streaming because that is the only way it can be echoing. Okay, can we proceed? Can we proceed? Can we proceed, guys? Let me know. Let me know. Can we proceed? Okay, can we proceed? Can we proceed? Can we proceed? Let me know. Let me know. Can we proceed? If we can proceed, say yes. Say yes. Say yes. Say yes. Okay, wisdom. John says right on. E for energy. I like that. Kingsley, why can't we proceed? Okay, wisdom. John says right on. E for energy. I like that. Please, why are you full of savage? Please. E for energy. Yeah. So the next thing we'll now look at is water and treatments. Ladies and gentlemen, the next thing we are looking at is water and treatment. So the next thing we'll now look at is water and treatment. Water and treatment. Now, the common source of water is rainwater, is rainfall. So the common source of water is rainfall, right? Now, if how do we treat this water? Now, the addition of chlorine to water is known as chlorination. I repeat. Now, the addition of chlorine to water is known as chlorination. Now, why are we adding chlorine to water? What is the reason for adding chlorine to water? It's simply to kill germs. It's simply to kill germs. So most of your past questions always say this. What is the reason for chlorination? The answer is to kill germs. I repeat, the reason for chlorination is to kill germs. Now, moving forward, how do industry treat water? How do industry treat water? Now, even in our swimming pool, some of you go to the pool a lot. They add chlorine to this water. So, like I was asking or was saying, that how do industry treat water, industrial treatment? Now, they treat water by the addition of alums. So we have the potassium alum and we have the sodium alum. Please listen, this is a jam question. H0, my mic is on. Potassium alum, and we have the sodium alum. This is the jump question. H0, my mic is on. Now, moving forward, when we add this alum, either it is potassium or either it is sodium alum, or when we add it to water, it's going to make the germs or bacteria or the dirty, that is purification. Jerry is asking, what about purification? Addition of alum makes this impurity to coagulate. Jerry, are you following? When we add alum to water, it's going to clump the impurity. Coagulating means that they are coming together. They are coming together. When we add alum to water, it's going to clump. Yeah, everything I'm saying is on the screen. Look at the spelling. This is spelling of alum. Everything I'm saying is on the screen. Spelling. All right, look at the spelling, guys. So when you add alum to water, it clumps, right? So you can simply remove the what? The impurities. Now, after removing the impurities, you still need to remove the germs. Then you now add chlorine again. Now, hope you know that chlorine is there to kill germs. Are you following, guys? Are you following? So remember, for water treatment, to remove impurities, add alum. The alum is going to coagulate the impurities to settle down. So we can simply remove by filtration. And after doing that, we can add chlorine to kill the germs that is still left. Are we together? All right. After doing that, we can add chlorine to kill the germs that is still left. Are we together? Now, the next thing we'll look at is hardness of water. Hardness of water. If you are still following, say E for energy. E for energy. John say, does this mean that after the industrial treatment of water, you can, yes, you can chlorinate. You can chlorinate. After adding alum, you can put in chlorine. No, sir. Water does not make alum strong, Gabriel. Water does not make alum strong. That's the next thing we'll talk about. So just relax. Sit back and relax. Water does not make alum strong. That's the next thing we'll talk about. So just relax. Back and relax. All right. So someone said they can't see the word. I'm going to try from my end. All right. So someone said they can't see the word. I'm going to try from my end. Okay. Let's go now. Now, quickly, what is hardness of water? What does it mean when we say water is hard? Let's go now. Hard water does not form leather easily with soup. What does it mean? If you are washing with hard water, it will be difficult for the water to form foam. All right, to form foam. That foam is the ladder. Sometimes when you are washing, when you add soap, especially detergent, the water is not foaming. You keep adding, you keep adding, you keep adding, you keep adding. You keep adding, you keep adding soap to it. See, the soap is not forming foam. The water is not forming foam. That water is referred to as hard water. The water is not forming foam. That water is referred to as hard water. Now, what causes this hard water? Now, the cause of hard water is dissolved salts. These solutes. Now, what causes hard water? Magnesium salts and calcium salt. Calcium tetraoxo sulfate 6, right? Compounds, magnesium tetraoxo sulfate 6 compounds. They are all, both of them are the cause of hard water. Right? Compounds, magnesium tetraoxo sulfate 6 compounds. They are all, both of them are the cause of hard water. Are we ready? So we said calcium salt and magnesium salt causes hard water. Now, how does this originate? For example, let's get a limestone. This is a limestone. Are we ready? So we said calcium salt and magnesium salt causes hard water. Now, how does this originate? For example, let's get a limestone. This is a limestone. Let's get a gypsum as well. All right. So let's react this. Let's get a gypsum as well. All right. So let's react. Now, ladies and gentlemen, look at this reaction. Limestone. I think I need to use black. Now, ladies and gentlemen, look at this reaction. Limestone. I think I need to use black. Now, limestone reacts with carbon dioxide plus water to give us calcium bicarbonate. Now, this is soluble in water. Because it is soluble in water, it causes hardness of water. Now, this is soluble in water. Because it is soluble in water, it causes hardness of water. Now, let's now move forward to types of hard water. Types of hard water. Types of hard water. Types of hard water. Number one, we have the temporary hardness. Number one, we have temporary what? Hardness. We have the temporary hardness. So this number one compound, sodium bicarbonate, causes temporary hardness of water. Sodium bicarbonate causes temporary hardness of water. Are we still following? Now, how do we remove temporary hardness of water? We simply put in the kettle and boil. At the end of the day, there's kettle fury. Those things you can scrub out of the kettle, those black and white deposits of this salt will be left. So the steam that is going to come out, those things you can scrub out of the kettle, those black and white deposits, the fume that is going to come out is free from hardness. Now, to be sure that you understood what I said, here's a question for you guys. This is PTS, JAMB, and WAEC question. Please, to be sure that you understood what I said, give me your answer. Here's the question for you guys. This is PTS, JAMB, and WAEC question. Please, give me your answer. I'm waiting. I'm waiting. Ladies and gentlemen, let your comment keep rolling in. E for energy. E for energy. E for energy. Ladies and gentlemen, let your comment keep rolling in. Come on, show me how you want to destroy this jam. Show me how you want to destroy these PTS and WAEC exams. How you want to destroy this jam. Show me how you want to destroy these PTS and WAEC. Alright, is this bold enough, guys? Show me, show me, show me, guys. Show me, guys. Alright, is this bold enough, guys? Which of the following method can be used to remove temporary hardness of water? A. Boiling. B. Filtration. C. Distillation. D. Chlorination. Which of the following method can be used to remove temporary hardness of water? A. Boiling. B. Filtration. C. Distillation. D. Chlorination. Alright, the answer is indeed A. Alright, the answer is in A. Now, the second thing we'll now look at, Bran, my mic is on. My mic is on. Now, the second thing we'll now look at, Bran, my mic is on. My mic is on. Now, the second thing we'll look at is permanent hardness. Permanent hardness. Now, permanent hardness can be removed by adding chemicals. Remember, we said that temporary hardness can be removed by boiling. So, impermanent hardness can be removed by, yes, ogeshi, slack lime. Slack lime is the same thing. Slack lime causes hardness and temporary hardness of water, right? When it combines with carbon 4 oxide and water, causes temporary hardness of water. I just said that now. Temporary hardness of water, right? When it combines with carbon 4 oxide and water, causes temporary hardness of water. I just said that now. Now, moving forward, permanent hardness can be removed only by chemicals. An example of that chemical is washing soda and caustic soda. Washing soda and caustic soda. Only by chemical. An example of that chemical is washing soda and caustic soda. Wash your screen. Wash your screen. Look at these equations. Wash your screen. Wash your screen. Now let's look at some questions. Okay, before we look at some questions, the last thing we talk about before we start calculating. Now let's look at some questions. The last thing we talk about before we start our calculation is saturated and unsaturated solutions. The last thing we talk about before we start our calculation is saturated and unsaturated solutions. Now, guys, look at these two glasses of water. We have A and we have B. We have glass A and glass B. Two glasses of water. We have Now, in glass B, those dot things that you can see is known as the solute. Remember, the solute are the things that dissolve in solvent. So let's assume they are salts. If my mic is echoing, it means that you are multi-streaming. Please close one stream. So moving forward, we have glass A. In glass A, you can see that those dots, they are few. What am I trying to explain? Those plenty dots that you can see is showing that the container is almost satisfied. Like, it be like when person chop belle full and another person see they hungry. One chop belle full, one don still chop o, but e never dey belle full. Let me use that. One is feed, one is not completely feed. Now, the one that is completely feed is known as saturated solution. E mean say e don belle full. So saturated solution is the maximum amount of solute dissolved. That is, all the solute it has dissolved is maximum. It has reached its highest length. So therefore, it doesn't have room to eat again. It doesn't have room to dissolve more solute again. Then why unsaturated solution, they are not feed. They never chop belle full. So therefore, they still have space to dissolve more solute. They have more space to dissolve more what? Solute. More solute can still dissolve. Now, ladies and gentlemen, if you are still following, please type I am following. I am following. E for energy. E for energy. I'm waiting. Now, ladies and gentlemen, if you are still following, please type I am following. I am following. E for energy. E for energy. I'm waiting. All right. I'm glad. I'm glad. I'm glad. I'm glad. I'm glad. Now, the next thing we'll look at, some of you said you cannot see my screen very well, so I'll try to zoom. I'm glad. I'm glad. I'm glad. I'm glad. Now, the next thing we'll look at is solubility curve. Now, solubility is simply a plot. The solubility curve is simply a plot between concentration and temperature. Let me show you what I meant by that. Solubility curve is simply a plot between concentration and temperature. Let me show you what I meant by that. Can you guys see my screen very well? Solubility against temperature. Can you guys see my screen very well? Solubility against. See, I assure you, there's nothing here. This is very easy. The most easiest thing in my life. The most easiest thing in chemistry. This is the most easiest thing in chemistry, guys. This is this is just a graph representative. Now, are you seeing solubility? Are you seeing this is the solubility and these are the temperature? So the y-axis is for solubility and the x-axis is the temperature. So the y-axis is for solubility, and the
Now,
x-axis
look at this first compound.
the temperature.
Look at this first compound. This first compound dissolved. Sorry, yeah, this first compound dissolved at
Look at this
at
first compound.
35 degrees Celsius.
Solve. Sorry, yeah, this first compound solve at 35 degrees Celsius.
So, did you see how I traced it down? NaNO3, sodium trioxide nitrate 5,
So
dissolve at 35 degrees Celsius.
NO3 5 dissolve 5 degrees Celsius.
Now, to make you guys further understood this thing, let's look at this question. We are going to do it together. Don't worry, Mark. Let's do this together.
Make you guys put down to
Firstly,
let's look at this question. We are going to do it.
look at this question. Look at this question. The solubility curve shows the variation of solute concentration with dash.
Firstly, look at this question. Look at this question. The solubility curve shows the variation of solute concentration with dash.
All right, D is indeed the answer. I'm glad you guys are following.
All right, this is indeed the answer. I'm glad you guys are following.
Now, look at what I mean. So we're going to answer this question together. Are we ready? Let's answer these questions together. Are we ready? Now the question says, for for which sort? Remember, all these things you see here are all sorts.
The question says,
All these things you see here are all sorts.
all these things you see here.
Now the question now says, for which sort in the graph above does the solubility increase most rapidly with rise of temperature? So the question is saying that which of these sorts increase in solubility? That's which of these sorts dissolve when temperature increases?
Which of these sorts increase in solubility? That's which of these sorts dissolve when temperature increases?
Okay, most of you are saying is B. So the answer is indeed B, ladies and gentlemen. The answer is indeed B. How? Let's look at it very well. We have solubility. We have solubility
Answer is indeed B. How?
against temperature, right? Now, when at 20, KNO3 dissolve at 20. Are you seeing it? At 20, KNO3 salt dissolve. Now, at
20 KNO3 salt dissolve. Now,
at let's now look at this salt. KNO3 again dissolved when it is at 50.
KNO3 again when it's at 50. Then at when the solubility is 40, then at when the solubility is 40, guys, are we together? Guys, are we together? So somebody ask how. Somebody ask how. Now let's look at the first KNO3. This KNO3, you can see that. Let me see if I can clean my screen. Now let's look at the first KNO3. This KNO3, you can see that. Now this first KNO3, can you see my screen? Is it protruding up? It's just directed up. So as the temperature begin to increase initially from 10 to 20, it just went up straight. So for this KNO3, it tells the story that it's dissolved, the solubility increased rapidly. The question asks rapidly. What is rapidly? Rapidly means very, very, very fast. So in all of these lines, which of them will you think goes up very, very fast, goes up rapidly? Ladies and gentlemen, is KNO3. Do you guys understand it? Goes up rapidly. Ladies and gentlemen, KNO3. You guys understand it? All right. So let's move forward. Ladies and gentlemen, this is the main thing for tonight. So if you are ready for calculation, say calculation. Say calculation. If you are ready for this section, say calculation. So if you are ready for calculation, say calculation. Say calculation. If you are ready for this section, say calculation. Ladies and gentlemen, if you are just new to this channel, see what is displaying on the screen, the bottom of the screen. It says, if you are new here, subscribe today. If you are new here, subscribe today. Subscribe to this channel to be a bona fide member of WAEC Academy. All right. All my guys are saying calculation. All my guys are saying calculation. Calculation we go. All right. All my guys are saying calculation. All my guys are saying calculation. Calculation we go. All right. Let's go now. Now, to calculate solubility, write it down. To calculate solubility, it is S. Let's go now. Now, to calculate solubility, write it down. To calculate solubility, it is S. S stands for solubility. S stands for solubility. It is S equals to gram over volume over another over. This is division sign. This division sign and this division sign are the same. Hope you know this is division and this is division. This is division sign. This division sign and this division sign are the same. Hope you know this is division. So
it is grams over volume over molar mass, close brackets, times 1000. So it is grams over volume over molar mass, close bracket, times 1000. Now this is the first question. We are going to solve it together. Now the question says, if 10.5 gram of lead 2 triazonitrate 5. Now this is the lead 2 triazonitrate 5. This is the lead 2 triazonitrate 5. I believe you all can see this question very well. It says if 10 is temperature. Favor, you're asking what makes the solution to increase rapidly. It's temperature. It's temperature. The question stated it. Temperature. Please take note. All right. So let's look at this. Let's look at this. Let's look at this question. So let's say if 10.5 of lead 2 triazonitrate 5, this is lead 2 triazonitrate 5. I circled it. Of lead 2 triazonitrate 5, this is lead 2 triazonitrate 5. I circled it. All right. So the questioner says is dissolved at 20 cm cube in distilled water at 18 degrees Celsius. Please, the 18 degrees Celsius is not important. The questioner asks, what is the solubility? The question is now asking, what is the solubility, guys? Now, how do you do that? Recall, what is the formula to calculate solubility? Is grams over volume, which is grams stand for mass over volume, division sign, molar mass times 1000. Now, the first thing we'll do is to select the G, the grams from this question. Now, what is the grams? The grams is 10 point. G is equals to 10.5, right? What about the volume? V is equals to 20. Okay. Let's see how we'll go about it. Step 1. Let's calculate the molar mass of lead 2 triazonitrate 5. Now, to calculate the molar mass of lead 2 triazonitrate 5, we must recognize that we have one lead in this compound. We have 2 nitrogen, because these two here, if you use it to open the bracket, is 2 times nitrogen plus this 2 times oxygen is already having 3 atoms, right? So 2 times 3 atoms is 6 oxygen. So what is our value for PB? Value for PB is 207. Value for nitrogen is 14. Value for oxygen is 16. Are we there? So let's apply it here. So PB, we substitute PB 207 plus, what about N? N is 14, right? So let's apply here. So PB, we substitute PB 207 plus. So 2 times 14, N is 14, right? Then 6 times 16. So 2 times 14. Are you guys seeing it? Times 16. So if we do this, we have 24 plus, so if we do this, 6 times 16 is what, guys? We have 24 plus is 96. So 24 plus 96 is 120. So so 24 plus 96 is 120. So okay, I think I must have made mistake here. Yeah, Mark, I see it. I must have made mistake here. So I think this is 120, right? Am I calculating it correctly? Okay, this is 28. Sorry, not 4. This is 28. So sorry. Okay, this is 28. Sorry, not 4. This is 28. So sorry. So this is 28. So when you add 124 plus 207, it's going to give you 331. So remember, the first thing is to calculate the molar mass, which we just did here. So remember, the first thing is to calculate the molar mass, which we just did here. All right, watch your screen. Yeah, thank you, John. I see it. I see it, Marvel. Thank you very much. So this is the first thing we do. Then what about the second thing? We will now apply the solubility formula. Yeah, thank you, John. I see it. I see it, Marvel. Thank you very much. So this is the first thing we do. Then what about the second thing? We will now apply the solubility formula. So what is the solubility formula? It says that so what is the solubility formula? It says that G divided by V divided by molar mass, right? So what is our G from the question? From the question, our G is 10. Are you seeing it? What about our V? Our V is 20.
From the question, our G is 10.
Now, substituting it here, it will be 10.5 divided by 20. It's going to give us this.
Now, substituting it here,
It will give us
it will be 10.5.
0.525.
Going to give us
0.525 divided by the molar mass again, which we just calculate to be 331, right? So 0.525 divided by 331
0.525.
gives us 0.
The molar mass again, which we just calculate to
0.00158. Are we there?
So 0.
Now remember the last step,
by 331
multiply by 1000.
gives us 0.
Multiply by 1000. So if we multiply by 1000,
Now remember the last step.
we're going to have 1.58 as an answer. Do we understand? 1.58 as our answer. 1.58. So if we look at these options given, we have A 1.6, B 5.56, C 16, D is what? 5.525. So let's now look at our calculation. This is our calculation. We got 1.56. So we can approximate this guy.
So let's now look at our calculation.
We can approximate this guy to give us 1.6. To give us 1.6. All right. Patricia has solved. So if we have 1.6, it means that option A is very, very, really correct. Option A is very correct. Mark has solved. I'm glad. Moving forward, let's solve this other one to ensure that you guys understood this.
Moving forward, let's solve this other one to ensure that you guys understood it.
All right, so we are still going to solve together as usual. Okay. Now we have a question before that says the solubility in mole per dm cube of 20 grams of CuSO4 dissolve 100 cm. Now they said, what is the solubility? And they said calcium is 63.5, approximately 0.5. Yeah, Mark, I am solving it right now. This is the question we are about to solve. So just listen. I can't see Bliss, oh. So sulfur is given as 32, oxygen is given as 16. Now, what's the first thing we'll do? The first thing we'll do is to calculate the molar mass of CuSO4, copper tetraoxosulfate 6. Now, we know that in this compound, we have copper, one copper, we have one sulfur, and we have 4 oxygen. Oxygen is coming from this guy, from the compound, 4 atoms of oxygen. So the value of copper is 64, value of sulfur is 32, value of 4 times 16 is 64. How do I know? It is given in the question, right? This, can you guys see it? Moving forward, what is the total, the mass? Everything come out 160. Everything came out 160. Are we together? Now, step 2 is to apply our grams over volume over molar mass. Now, what is our grams? Our grams is 20. Our gram is 20. Can you see our gram? It's 20. And our volume is 100. So the first thing we do is 20, which is grams. You can see the blue, the grams, over 100. 20 over 100 gives us 20 over 100 gives us 0.2, right? Now the next thing is we divide again with molar mass. What is our molar mass? We calculate molar mass to be 160, right? So 0.2 divided by 160, it comes out 0.00125. Now 0.1125 multiplied by 1000. Now 0.1125 multiplied by 1000. If you multiply it by 1000, it comes out 1.25. So ladies and gentlemen, the answer is 1.25. So let's look at the option. If 1.25 is there, ladies and gentlemen, we have 1.24. So option C is the correct answer. Do you guys understand this? Comment. Is it clear? If you understand, say I understand. Say I understand. Say I understand. If it's clear, say I understand, because you will solve one now. If you understand, say I understand. Say I understand. All right, ladies and gentlemen, let's solve this and go and sleep. All right, ladies and gentlemen, let's solve this and go and sleep. All right, I'm glad you guys do understand. Let's go. Solve this for me now. Let's go. Watch your screen. Watch your screen, guys. Glad you guys do understand. Let's go. Solve this for me now. Watch your screen. Let's go. Give it to me right now. Say E for energy. You say whip and come. I want to solve. Wisdom. Okay. If you are ready to solve, say whip and come. I don't whip and come. Wisdom. Solve am. Wisdom. Solve am. I don't whip and come. If you are ready to solve, say whip and come. Come, wisdom. Solve am. Wisdom. Solve am. I don't whip and come. Try this, ladies and gentlemen. Try this. This is coming from Solubility.
Try this, ladies and gentlemen. Ladies and gentlemen.
Marvel say whip and come, whip and come. And he say whip and come, and I did whip it. Okay,
Marvel say whip and come.
all right, okay.
And he say whip and
Let me add it. Let me add it quickly. Sarah said, "Yeah, it's not there." Okay, let me quickly add it.
Okay. All right. Okay. Let me add it. Let me add it quickly. It said, yeah. Okay. Okay. Let me.
K is equals to 39
K is equals to 39.
and O is equals to 16. I believe you guys can see this clearly now, so you have no excuse. Solve it.
O is equals to.
All right, wisdom say whip and come. Wisdom solve. Oh.
So you have no excuse. Solve it.
Say whip and come.
Wisdom solve.
Okay, Estheogene root says is 2 mole, which is E. Harvest Okpako says is E. Wisdom that is saying whip and come. You don't stop.
Which is E. Harvest Okpako says
Loma says is E. Faith, we know you understand. Solve these ones for us. Solve it, solve it, solve it. Oh yeah, nah. Let's go now. Oh yeah, nah. Let's go now. Solve it now.
Solve it. Solve it.
Ladies and gentlemen, if you are just new to this life, the first thing you do to become a bona fide member of Joyce Academy is to subscribe to our YouTube channel. All right, so you can see displaying on the bottom of the screen. Subscribe now. Subscribe today. Subscribe now. Subscribe today. So why others says their answer is E? Where is Mr. Bleeze? Where is Mr. Bleeze? Where is Kingsley? Where is Idigu Faith? Oh, where are you? Kingsley says is E. Kingsley, I'm glad you're following. Kingsley, I'm super glad. You can hear me. Marvin, I'm glad. Marvin, I'm glad. Where's Mark? My OG, Mark. Wisdom say whip and come. And Wisdom got D. Whip and come. Everybody they get. Everybody they get E. Everybody they get E. Wisdom. How far now?
Everybody they get E. Everybody they get E. Wisdom. How far now?
Yes, Mr. Bleeze. Mr. Bleeze. Yes, Blissful Bleeze. Okay, John says the answer now B approximately 0.25.
Yes, please.
Okay, somebody should show working on the comment section. Kingsley, show your working on the comment section. Kingsley, can you type fast? Harvest, can you type fast?
Still working on the comment section.
So, Wisdom is saying the answer is approximately 0.2, which is B.
Kingsley, can you type fast? Harvest, can you type fast?
Wisdom, I don't whip question come. Oh.
Wisdom is saying the answer is approximately 0.2. Wisdom, I don't whip question come.
right, ladies and gentlemen, the answer is indeed E. Is the answer 2 moles. The answer is indeed E. Yeah, SU organic roots. I'm proud. I'm glad. I'm glad. I'm glad. It shows that you guys understood. So, ladies and gentlemen, let me quickly take you guys from where we are coming from. So tonight we did solubility, solutions, and uh, water. So we look at the concept of solute, solvent, and solution, then solubility. Remember, this is what we did. We look at what is solute, what is solvent, what is solution, and we said that water is a universal solvent. All right. So we look at the factors affecting solubility. We answered few questions. We look at water treatment where we talk about chlorination and alums. We look at types of hard water and what causes hardness. We said it is calcium salt and magnesium salt. Types of hard water, we said temporary. Temporary hardness can be removed by boiling. And moving forward, we look at some questions. We talk about permanent hardness of water, right? And we differentiate between saturated and unsaturated solutions. Then we look at solubility curves. We said that when a solution, when a solution, when the solubility increases rapidly, what causes it is temperature. Then we look at calculations. Now, this is the formula we said we will apply to solve questions under solubility. Then we look at the first question, second question, and I gave you guys a work to do. Now, ladies and gentlemen, if you understood all that has been said today, is another time to remind you that if you've not subscribed to this channel, please do that now. And if you have question before we go, please ask your question now. If you have a question, ask your questions now. Wisdom, how far? If you have question, ask your questions now. So, in the absence of no question, let me remind you that our next live class is on Tuesday. Our next live class is on Tuesday. So get prepared. Ladies and gentlemen, the exam is fast approaching, so we need to be learning, if possible, possibly every day. Yes, if they ask you roots, if they ask you to find the grams per dm cube, right? Solubility must be given. You cannot solve with two unknown. That's a good question. SK, I see you. Wisdom, you know, go whip questions. Wisdom, you know, whip question come again. How far? So, ladies and gentlemen, I think let me put on my camera. That's a good question. SK, I see you. Wisdom, you know, go whip question. Wisdom, you know, whip question come again. How far? All right. Ladies and gentlemen, boys and girls, thank you very much for making this live session possible. For the caustic soda and permanent hardness of water in the formula. Okay, what is the formula?
Please, is on the slide. Just go back. You're gonna see it, right? You're gonna see it. It's on the slide. It's on the slide. So any question, maybe anywhere you don't understand, right? Okay, Mabe, okay, Bleeze. Oh, Bleeze is just coming online and we are running up. No come online like this when rapture don't take place, finish. Alright, ladies and gentlemen, good night. Do have a good night rest. Bye.